This is America in Space, a weekly news and information program on current events dealing with the space industry.
Welcome, and thanks for joining me today. I'm Dawn Meyer, Space Coast News Editor. Scientists are using 3D bioprinting in space aboard the International Space Station to create tissues and organoids that would otherwise be difficult to make in the presence of gravity. The standard process of 3D printing, also known as additive manufacturing, enables the design and production of one-of-a-kind items made of plastic, metal, and other materials that include things like tools, equipment, and even buildings. Biological printing, or bioprinting, however, uses living cells, proteins, and nutrients as raw materials, and has the potential to produce human tissues for treating injury and disease, and even to create entire organs for transplants. Redwire Corporation developed the Biofabrication Facility, or BFF, as a part of the larger goal of using microgravity to bioprint human organs in space. Here is more from them on the process.
In certain situations, the loss of gravity can be a good thing for cells and humanity alike. One of those cases is 3D bioprinting. Like typical 3D printers that expel layers of plastic on top of each other to create a structure, a 3D bioprinter uses bioink, a mixture of cells and thickening components, to print layers of cells. The main printing component of a 3D bioprinter is the print head, which has a nozzle that releases a stream of bioink in a single layer on a surface. The print head then goes back over that first layer of cells with another layer, following a programmed route. Scientists can take computed tomography, CT, or magnetic resonance imaging, MRI, data from a patient, use it to create a 3D model, and print a cellular structure that is completely personalized to that patient. To become functional tissues, these 3D printed structures need time and specialized conditions to mature. Once these cellular structures mature into tissues, scientists can use them as models for pharmacological testing or even as tissue and organ transplants one day. When scientists print these delicate cellular layers on Earth, however, gravity pays them no favors. Researchers must use scaffolds to support the layers so that they don't collapse into a pile of cellular goo. Because of this, it is very hard to print tissues that need intricate vasculature to function, such as cardiac tissue. While many scaffolds are biocompatible or biodegradable, simply their presence in 3D printed cellular structures can affect the functionality and the shape of the final 3D printed tissue. But in the weightlessness of space, 3D bioprints don't need scaffolds at all. In the absence of gravity, you can print three-dimensional structures, tissues that more closely resemble the actual structures here on Earth, said Michael Roberts, the Chief Scientific Officer of the International Space Station, National Laboratory. It's a very interesting space to explore possibilities of making tissue-like products that can be used here on Earth, but they're made in space, and they have superior performance characteristics. Now, space agencies around the world as well as private companies are developing 3D bioprinting capabilities for use in space. They aim to create better organoid models for basic science and pharmacological testing, as well as tissues and eventually organs that astronauts can print on station and either use themselves or send back down to Earth.
Crew 7 astronaut Andre Mogensen recently spoke about the experiments they did using the bioprinter.
International Space Station is an incredibly versatile laboratory, but one of the things that really appeals to me is the idea of printing tissues, human tissues, for example. We have a biofabrication facility up here that allows us to print tissue simulants, for example, even simulants of human organs, and take advantage of the microgravity environment, which allows us to print in 3D rather than in an Earth laboratory where it's usually cell cultures are grown in a two-dimensional surface. And I think that's a very, very promising technology and very, very interesting one that we've been working with during our mission so far. Well, so for example, a human heart that allows us to study cardiac functions. I mean, if we look far in the future, perhaps we could print organs rather than relying on organ donors. A lot of people on Earth require organ donation, and unfortunately we're limited on the supply, and a lot of people aren't lucky enough to have an organ donated. So perhaps in the future we would be able to print organs and rather than having to rely on donors.
It's amazing to me that ordering an entire organ created aboard the International Space Station is getting closer to reality. Thank you for joining me, and thank you for listening from your home or where you work. Listen each Tuesday for This Week in Space with John Gomez. And join me every Friday for America in Space. From the Florida Space Coast, I'm Dawn Meyer, Space Coast News Editor for About Space Today.
Thanks for listening. Be sure to share our program with your family and friends and follow us on Facebook. Join us each week for news and information on America in Space.